So look around you, that massive skyscraper downtown, the bridge you drive over every day, the very pipes that bring water to your house, they all have something in common. They were built by civil engineers, the unsung heroes who literally shaped the world we live in. For centuries, they've used slide rules, then calculators, and then powerful computers. But what if I told you they're about to get a new superpower? One that's so game-changing it makes everything that came before look like building with Legos. I'm talking about artificial intelligence, and it's not some far-off sci-fi concept. It's happening right now, and it's quietly starting a revolution in concrete and steel. This isn't just about making things a little faster or a little cheaper. AI is fundamentally rewriting the rules of what's possible in civil engineering. Think of it like giving every engineer a team of 1 million brilliant assistants who have studied every construction project in history, can see into the future to predict problems, and work 24/7 without a coffee break. It's a massive upgrade for humanity's master builders. And trust me, the results are going to be mind-blowing, affecting everything from the safety of our buildings to the sustainability of our cities. So today, we're going on a deep dive. We're going to pull back the curtain and look at the 7 key ways AI is already transforming civil engineering. We'll see how it's creating designs that were once thought impossible, how it's acting as a guardian angel for our infrastructure, and how it's paving the way for the smart cities of tomorrow. So grab your hard hat, because we're about to explore the incredible intersection of ancient engineering principles and cutting-edge artificial intelligence. This is going to be awesome. Okay, so first up, designing the thing. Before a single shovel hits the dirt, engineers spend thousands of hours in the design phase. They have to consider physics, materials, cost, regulations, and a million other variables. It's like solving a giant, three-dimensional puzzle with incredibly high stakes. Traditionally, this involves a lot of trial and error. You try a design, you run a simulation, you find a flaw, you tweak it, and you repeat. This can take months. But now, enter generative design. This is where engineers don't just use AI as a tool, they partner with it. Instead of drawing a bridge, an engineer can now tell the AI, okay, I need a bridge to span this river, support this much weight, withstand these wind speeds, and use the least amount of steel possible. The AI, like a brilliant student who has aced every physics exam ever, doesn't just give one answer. It generates thousands of potential designs in the time it takes to grab a coffee. It explores weird, organic-looking shapes that a human might never think of, but which are incredibly strong and efficient. We're talking about structures that look like they're straight out of a sci-fi movie, but are mathematically perfect for the job. This partnership is a total game changer. The AI handles the heavy lifting of crunching all the numbers and exploring every possibility, freeing up the human engineer to focus on the bigger picture: creativity, user experience, and aesthetics. Machine learning algorithms can also suggest the best materials to use based on climate data, or optimize a building's layout for maximum natural light and energy efficiency. It's not about replacing engineers. It's about giving them a creative co-pilot that helps them design buildings and infrastructure that are smarter, greener, and more resilient than ever before. Alright, so you've used AI to design and build an amazing bridge. Awesome. But how do you make sure it stays safe for the next 100 years? Bridges, tunnels, and tall buildings are constantly under stress from traffic, weather, and just plain old age. In the past, checking on them meant sending out a team of inspectors to visually look for cracks, which is slow, expensive, and you can easily miss something tiny but critical. It's like trying to find a single typo in a million-page book. This is where AI becomes a tireless guardian. Today we can embed thousands of tiny, inexpensive sensors throughout a structure. Think of them as nerve endings for the building. These sensors measure everything in real time: vibration, strain, temperature, even the chemical composition of the concrete. They generate a fire hose of data, way too much for any human team to analyze. But for an AI, it's a piece of cake. The AI constantly listens to the heartbeat of the structure, learning what normal behavior looks like. It knows exactly how the bridge should vibrate when a heavy truck drives over it on a hot summer day. So when something changes, even slightly, the AI spots it instantly. It can detect a microscopic crack forming deep inside a concrete pillar long before it's visible to the human eye. It doesn't just raise an alarm, it can predict the future. By analyzing the data trends, it can say, based on the current rate of corrosion in Sector 7B, there is a 95% probability of a critical failure in the next 18 months. This allows maintenance crews to go in and fix the problem proactively, before it becomes a disaster. It's a shift from reactive repairs to predictive maintenance, making our infrastructure incredibly safer for everyone. Now for the really cool part, the construction site itself. For decades, construction has been one of the least automated industries. It's messy, it's complex, and it happens in an ever-changing environment. But AI is finally bringing the robots. We're not talking about C3PO laying bricks, but specialized machines powered by sophisticated AI that can perform tasks with superhuman precision and endurance. Think about bricklaying. It's a repetitive, physically demanding job. Now there are robotic arms that can lay thousands of bricks a day, perfectly aligned without getting tired or needing a lunch break. And it's not just on the ground. Look up, and you'll see AI's eyes in the sky drones. A drone equipped with a high-resolution camera and LiDAR can survey a massive construction site in minutes, a job that would take a human crew days. The AI then stitches all this data together to create a perfect, up-to-the-minute, three-dimensional model of the site. The project manager can then compare this model to the original blueprints to track progress with incredible accuracy. They can see if a foundation is off by a few centimeters or if a delivery of steel beams was left in the wrong place. This level of automation is transforming the entire workflow. We have autonomous bulldozers and excavators that can grade a site to precise specifications using GPS and AI guidance. We have robotic systems for welding and rebar tying, and then there's three-dimensional printing, where giant printers can extrude entire walls or even small buildings layer by layer, guided by an AI model. This isn't about replacing human workers, but augmenting them. It takes people out of the most dangerous and repetitive jobs, reduces errors, and dramatically speeds up the construction process. Building something huge, like a new airport or a subway line, is honestly one of the most complex logistical challenges on Earth. You're juggling thousands of workers, tons of materials, hundreds of subcontractors, tight deadlines, and budgets in the billions of dollars. A single delay, like a shipment of concrete being late, can cause a domino effect that costs millions. For a human project manager, keeping all of this on track is a monumental task. They rely on experience and, let's be honest, a lot of guesswork. But AI is here to take the guesswork out of the equation. Imagine an AI project manager that has analyzed every major construction project from the last 50 years. It's learned from every success and every failure. When planning a new project, it can run millions of simulations to find the most efficient schedule. It knows that scheduling electricians before the drywall is up is a bad idea, and it knows the optimal delivery time for steel beams to minimize storage costs and prevent delays. It can allocate resources, people, equipment, materials, with a level of precision that's simply impossible for a human. And it doesn't stop once the project begins. The AI is constantly monitoring progress in real time, using data from drones, on-site cameras, and worker reports. If it detects a potential problem, like a subcontractor falling behind schedule or a looming shortage of a specific material, it flags it immediately. It doesn't just identify the problem, it suggests solutions. It might recommend reassigning a crew from a less critical task or ordering from an alternative supplier. This is risk management on steroids, helping to keep these massive, complex projects on time and on budget. Okay, let's zoom out from a single project to the entire city. How we design our cities has a huge impact on our quality of life, the environment, and the economy. This is where urban planning, a branch of civil engineering, comes in, and AI is giving planners an incredible new toolkit. Cities generate an unbelievable amount of data, from traffic patterns, public transport usage, energy consumption, water usage, and air quality sensors. In its raw form, it's just noise. But AI can analyze this data to find hidden patterns and insights. For example, by analyzing traffic flow data from GPS and road sensors, an AI can design a smart traffic light system that adjusts its timing in real time to reduce congestion and cut down on commute times for everyone. It can identify the best locations for new bus routes or bike lanes by seeing where people are actually trying to go. It can help design greener buildings by simulating how different designs and materials will impact energy consumption for the entire city block, not just a single structure. It's about making data-driven decisions on a massive scale. This leads to the concept of a truly smart city, where the entire infrastructure is interconnected and optimized by AI. Imagine a city where the power grid automatically reroutes electricity to prevent blackouts during a heat wave, where the water system can instantly detect and isolate leaks to conserve water, and where emergency services are automatically dispatched to accidents the moment they happen. This isn't a futuristic dream. AI is the engine that will power this, creating urban environments that are more efficient, sustainable, and livable for all of us. So far, we've talked a lot about the structures we build on top of the ground. But what about the ground itself? This is the realm of geotechnical and environmental engineering, and it is critically important. The soil, rock, and water beneath the structure determine its stability. Getting this wrong can lead to catastrophic failure. Traditionally, engineers would drill a few boreholes, take some soil samples, and then make educated guesses or extrapolations about what the conditions are like across the entire site. It's a bit like trying to understand a whole book by reading just a few random pages. AI changes this completely. By feeding an AI model data from satellite imagery, ground-penetrating radar, seismic sensors, and those traditional boreholes, it can build a highly accurate three-dimensional model of the subsurface. It can predict soil behavior, identify hidden pockets of unstable ground, or map out the flow of groundwater with incredible precision. This allows engineers to design foundations that are perfectly suited to the actual ground conditions, making structures much safer and often more cost-effective. This predictive power is also vital for environmental protection. AI can analyze satellite data and climate models to predict the risk of landslides in hilly regions after heavy rainfall, giving communities time to evacuate. It can model how pollutants might spread through groundwater, helping to plan effective cleanup strategies. It can even assess the environmental impact of a new dam or highway before it's built, allowing engineers to choose a path that minimizes harm to natural habitats. AI is giving us the vision to see and understand the complex, hidden world beneath our feet. Okay, last but definitely not least, safety and quality. A construction site is one of the most dangerous workplaces in the world, and ensuring that every weld, every bolt, and every concrete pour meets exacting quality standards is a monumental task. Human inspection is essential, but people get tired, and it's impossible to be everywhere at once. This is where AI-powered computer vision comes in. It's like having thousands of expert inspectors with superhuman eyes watching over every inch of the project, 24/7. Imagine a camera mounted on a crane that scans the steel frame of a skyscraper as it's being assembled. An AI vision system analyzes the video feed in real time. It can detect if a bolt is not tightened to the correct torque, if a weld is defective, or if a steel beam has a microscopic crack that would be invisible to the naked eye. It instantly flags the defect, showing its exact location on a three-dimensional model so a human worker can immediately correct it. This moves quality control from a spot check process to a 100% coverage process, dramatically reducing the risk of structural failures. This same technology is a game changer for worker safety. AI-powered cameras can monitor the entire site for unsafe conditions. It can detect if a worker enters a dangerous restricted zone. It can verify that everyone is wearing their personal protective equipment, like hard hats and safety harnesses, and send an alert to the site foreman if someone isn't. It can even identify risky behaviors, like working too close to heavy machinery. The goal isn't to spy on workers, but to create a smart safety net that helps prevent accidents before they happen, ensuring more people go home safely to their families at the end of the day. So, what does this all add up to? We've seen how AI is becoming the ultimate co-pilot for civil engineers, from the initial design all the way to long-term maintenance. It's not about robots taking over. It's about human ingenuity being amplified by the incredible power of artificial intelligence. The benefits are crystal clear. AI saves an enormous amount of time and money by optimizing schedules and resources. It drastically reduces errors by catching tiny flaws humans might miss. It massively improves safety for both the public using the infrastructure and the workers building it. And ultimately, it enables us to create smarter, more efficient, and more sustainable designs that were simply out of reach before. This isn't just an incremental improvement. It's a fundamental paradigm shift in how we build our world. We are at the very beginning of this revolution, and the things we've talked about today are just the first few steps. The core job of a civil engineer, to solve problems and build a better future for humanity, will always remain. But their tools are becoming exponentially more powerful, allowing them to tackle bigger challenges than ever before, from climate change to rapid urbanization. So what does the future hold? The sky is literally the limit. Think fully autonomous construction sites, where a team of robots coordinated by a central AI builds an entire structure from the ground up. Think self-healing infrastructure with materials that can repair their own cracks. And think about entire AI-driven smart cities that operate in perfect harmony with their inhabitants and the environment. It sounds like science fiction, but based on what we're already seeing, it's the blueprint for the world our children and grandchildren will live in. The future of civil engineering is here, and it's being built with code as much as it is with concrete.